Hello, so today we want to synthesize pattern of a 4 element antenna array that are fed with currents of equal magnitude and same phase, and the distance with which they are separated are equal, and it is given by lambda by 2. So here you can see the 4 element 1 2 3 4 element antenna array are separated by a distance d is equal to lambda by 2. So what are the steps to actually synthesize pattern? First step is to find the individual pattern, or you can say unit pattern. For unit pattern, you know the total electric field formula is 2 E naught cos psi by 2. We know that psi is equal to beta d cos phi. Here we want to calculate the individual pattern of the points because we have created a group pattern, means the 4 element is now decomposed into 2 element, and these elements are A and B separated by the distance d is equal to lambda. So you can put the value of beta here, d is lambda by 2, and you can get the value as Et is equal to 2 E naught cos pi by 2 cos phi. Okay. To draw individual pattern, we must know the value of maxima, angle of maxima and angle of minima. So we know that cos will be maximum when it is equal to plus minus 1, and this value will be integral multiple of n pi. Here n is an integer, you can put the values and you can calculate the angle of maxima and minima. So it will be cos inverse plus minus 2 and 2 will be multiplied here. You can put n is equal to 0, you will get 0, and cos will be 0 at 90 degree, you can say 270 degree, but cos inverse 2 will not be defined. For minima or nulls, the cos pi by 2 must be equal to 0, and we know that it will be satisfied by this equation 2n plus 1 pi by 2. N is again an integer, and you can calculate the minima angle, that is 0 degree and 180 degree. Now you have to plot this individual pattern or the unit pattern. In 0 degree, 180 degree, 60 degree, 120 degree, you are not getting any lobe, but you will get maximum lobe or major lobe in the direction of 90 degree and 270 degree. Now step number 2. For pattern multiplication, we also need to find our group pattern. So A and B has a distance of lambda. You can again see this figure. If we take the mid section of this point, this will be at lambda by 4, and this will again be at the lambda by 4, and if we calculate the distance, it will be lambda by 2 plus lambda by 2. So they are separated, A and B are separated at a distance d is equal to lambda. So again you have to repeat the same process, but now you have to put d is equal to lambda. As you can see guys, we again put the value of beta is equal to 2 pi by lambda and d is equal to lambda, and we get the value of Et is equal to 2 E naught cos pi cos phi, and cos pi cos phi must be equal to integral multiple of n pi when we want our maximum condition to be satisfied, and it will be again at 90 degree and 270. When we put n is equal to 1, there will also be condition for maxima because now plus minus 1 will be defined. So it will be at 0 degree and 180 degree. So minima angle you can also calculate. It will be at 60 degree and 120 degree. You can always draw the pattern by calculating the angles of maxima and minima. Now look at this figure. This will be our group pattern of the area of antenna of point A and B, which are separated by the distance d is equal to lambda, and this figure shows the nulls direction, shows the major lobe direction, which will be at 0 degree, 180 degree and 90 degree, 270 degree. Now you must multiply individual pattern with group pattern to create your resultant pattern. So it will be the pattern of the 4 element antenna array. So how you multiply this? This is the unit pattern, this is the group pattern. Simply we have to multiply our nulls with nulls. So what we get? We have our nulls at 0 degree, 180 degree. So wherever we are getting nulls, we are getting nulls, and maxima multiplied by maxima will be maxima. So 90 and 270 angles we are getting maximum radiation. So that will be multiplied, and that will be our same pattern. So at 90 degree and 270 degree we are getting the major lobes. And because in individual pattern there is no no radiation occurring, or you can say there are nulls occurring, so the overlapping of patterns will occur and we will get side lobes. So when you multiply this by nulls you will get side lobes like this. So you can also practice more element antenna array. And if you like this video, please like, share and subscribe my channel.